A vector can have components, and the number of components depend on your choice. It might be ranging from 2 to any number of components. Mostly we take the components along two axes, that's x and y, and sometimes depending on the nature of our study we also refer to three axes. It is customary to write a vector in terms of components, and the components that we consider are along the axis of the coordinates. Like suppose it is x coordinate and y coordinate. There is a vector, say this one. So we consider one component along x-axis, the other along y. It's a vector A, then it would be ax and it would be ay. You could write this way. Unit vector, you know, a vector having magnitude equal to 1, and this is obtained by dividing a vector by its magnitude. The unit vector, because the quantities have been taken in the form of a ratio, unit vectors have no dimension and their magnitude is always fixed, that is 1. They have fixed direction. So we can write vector ax as axi, similarly ay as ayj. Then what we do, vector A becomes axi plus ayj, and so on. If it is a 3D vector, then we also extend it to k component. Now these are the components in terms of two axes. Similarly, if we have three axes, then it could be in terms of azk also. Now regarding the value of the given vector, you take the square root of sum of square of the two components or even three components depending on the type of vector we have chosen. If it is a 3D, you see, you must be aware while drawing 3D, one has to take care that these two are at 90 degrees. While the third axis will be this way. This is z-axis. Remember, plus z is normally outward, and when you take normally downward, this would be known as minus z. At the same time, right of the origin, that's plus x, and left of the origin, that's minus x. Above the origin, it's plus y, and below the origin, it's minus y. A given vector must be having some angle with the axis x, y, and z. For drawing z-axis, the precaution needs to be taken because third axis is in another plane. So this is just impossible to draw as such because this plane is empty. It's just a space over here. So how we show the third axis? This is the way that becomes z-axis. While drawing on the notebooks or even on the board, we follow this method, but we keep in our mind that this is in another plane. Suppose there is a vector that's having angle alpha, beta, and gamma with the three axes x, y, and z. Then in that case, one should remember cos alpha would be ax is x component and a is the magnitude of the vector. Similarly, cos beta a y upon a, cos gamma is z upon a. One very important relation between these, you see, these are also known as direction cosine of the given vector. If you write the square of these and you just sum up, you'll find their sum equal to 1. And with the help of this relation, if you write all in terms of sine square alpha, sine square beta, sine square gamma, you are going to get this sum as equal to 2. One more thing, if I tell you that there is a vector that makes equal angle with x and y axis, obviously you'll just guess. This angle is 45 degrees. And in that case, you will also know that the two components shall be equal to each other. those components will be equal to, suppose the vector is A, then this component AX or even AY, it's going to be equal to A upon root 2. But if you consider that vector is making equal angle with all the three axes, then in that case, obviously all these will be equal. Then what you'll get is 3 cos square alpha equal to 1, cos square alpha, this is equal to 1 by 3, cos alpha equal to 1 upon root 3. And you must remember this value is obtained at angle about 54 degree. So when the vector is making equal angle with all the three axes, this angle is going to be equal to 54. And when the vector given makes equal angle with the two axes only, then this angle is equal to 45. You should remember.